Just some homework problems with divisibility induction. Prove that 47 to the power of n plus 53 times 147 to the power of n minus 1 is divisible by 100 for integers n greater than or equal to 1. Step 1, prove true for n equals 1. So it's 47 to the power of 1 plus 53 times 147 to the power of 1 minus 1. Well, that is equal to 47 plus 53 times 147 to the power of 0, which happens to be 1. So it's 47 plus 53 times 1, which is 100. Obviously, that is divisible by 100. Step 2, assume true for n equals k. That is, we're assuming, look, once you are doing this for a while, you can just go assume is true. Like assume 47 to the power of k plus 53 times 147 to the k minus 1 is true if you want. So that is, assume that equals 100 times p, where p is an integer. All right, so we're good with that. It's step 3. Prove true for n equals k plus 1. That is, we have to prove that 47 to the power of k plus 1 plus 53 times 147 to the k plus 1 minus 1 is divisible by 100. Now that's just 147 to the k, it will be. So I've just replaced my n's with my k plus 1. 47 to the k plus 1 plus 53 times 147, I'm just going to write that as to the power of k, is equal to 47 to the k times 47 to the power of 1 plus 53. Now, you know what's going to happen later is that we're not going to have like terms. All right? Oh, we might. Let's just see. Plus 53 times 147 to the k. Do you going to make your substitution now or not? What are you going to substitute? So we're going to substitute from here, and it's going to be 100p minus 53 times 147 to the k minus 1. So let's do that. This is not going to be very good, but you can do that, but you're not going to get anywhere. We need to do something.
Why don't we keep the k minus 1 and then plus 1?
We could do that. Actually, that's a good idea. And then you want to substitute for the second term instead.
No, that's not what I meant. I meant like
actually you
447.
Yeah.
But we'd have like terms between 147 k minus 1.
All right. All right. So you want to keep this as k minus 1 times 147 to the 1. We can do that. Yeah, or you can do it like that. Or if you did have it like that, you can just bring it back later. Look, there's many different ways of doing this, all right? Let's just see how we go here, whether this is going to work or not. So let's make our substitution for 47 to the k. So we're going to make the substitution for that. So 47 to the power of k, isn't that 100p minus 53 times 147 to the k minus 1? Now that's still being multiplied by what? By 47 plus 53 times 147 to the k minus 1 times 147. So what we did here, I'll just keep this as k minus 1 plus 1. All right, let's expand. So we're trying to prove that it's divisible by 100, isn't it? So I'm going to go 47 times 100p minus 53 times 47 times 147 to the k minus 1 plus 53 times 147 times 147 to the k minus 1. Now watch, I've got 47 times 100p. Now I'm going to put a plus 147 to the k minus 1 first, and I'm going to do this second term first, because that's minus that, plus this. So I'm going to, in brackets, go, actually, why don't I take out, all right, 53 times 147. You see what I'm doing? So I took out the 147 to the k minus 1, but I've got the 53 times 147 first because I put a plus here. But then I'm going to go minus, for the second one, minus 53 times 47. Close bracket. See what I've done? I've just changed the order of these two terms. See, this is one term and that's the other term. So I've got 47 times 100p plus 147 to the k minus 1. Now, what's 147 lots of 53 minus 47 lots of 53? 100 lots of 53. K minus 1 times 100 lots of 53. Can you see that? Girls, this is 53 times 147 minus 53 times 47. It's like 147 lots of 43 minus 47 lots of 53. 147 lots of 53 minus 47 lots of 53. Can you see it's 100 times 53 left over? So I've got two terms still. There's my first term, there's my second. 100 is a common factor. 47p plus 53 times 147 to the k minus 1. Now, because for n greater than or equal to 1 and we assume n equals k, the very first value of k that you would get here would be a 1. That would give me 147 to the power of 0, which is just 1. 47p plus 53 times 1 is a whole number. It's an integer. If k was 2, I would get 47 times some integer plus 53 times 147. Then I'd get 147 squared for the next value of k. So this is a whole number. This is going to be an integer, which equals 100 times q, where q equals all of that, which is an integer. Okay? And then you can do your conclusion. Just doing this an alternative way for step 3, you have to prove that 47 to the power of k plus 1 plus 53 times 147 to the k plus 1 minus 1 is divisible by 100, okay? So that is equal to 47 to the power of k plus 1 plus 53 times 147 to the power of k. Now, which is, let's break up the 47. 47 to the k times 47 plus 53, sorry, I shouldn't have done that second step, times 147, sorry, I don't know why I did that, because I'm going back. What I'm going to do, I'm going to swap these two around instead and go k minus 1 plus 1. So this is an alternative solution. We start with that. We're going to swap these two around. So we've got 47 to the k times 47 to the 1 plus 53 times 147 to the k minus 1 times 147 to the 1. Now, the reason I've done it like that is because if you look at the assumption, trying to make it look like the assumption with the 147 to the k minus 1. So now that is equal to, what's happened here is they're trying to substitute 47 to the power of k plus 53 times 147 to the k minus 1, the whole thing. They're trying to substitute the whole thing with 100p. So the problem was they didn't have that. They had this, 147 lots of this. This is all just one term. So if you've got 147 lots of that, you've got 47 lots of that plus 100 lots of just that. All right? So now what we can do here is with the first two terms, we can take out a common factor of 47, bracket 47 to the power of k plus 53 times 147 to the power of k minus 1. So 47 now is a common factor between these first two things, two terms. Plus we keep writing the rest. Plus 100 times 53 times 147 to the k minus 1. So now I can substitute this for what? 100p. So it's 47 times 100p plus 100 times 53 times 147 to the k minus 1. Now you take out 100. So look, girls, it's basically the same as what we've done, but we do 100 minus because it's easier, right? But they've broken up this 147 into 147 lots of that thing in front of it. All right? So therefore it's 100 bracket 47p plus 53 times 147 to the k minus 1, which is what we had before. That is exactly what we had before, which equals 100q, where q equals that bit. They've broken, see this that I've underlined? So you can finish this off and write the conclusion. Hence, if it's true for n equals k, it's also true for n equals k plus 1. Since it's true for n is 1, then it must be true for n is 1 plus 1, which is 2, 2 plus 1, which is 3, etc., and so on, for all n greater than or equal to 1. All right?